All right, so in this video, we are going to take our vector projections one step further. So what we're going to do is we are going to write vector v as the sum of the orthogonal vectors. Now, if you remember, orthogonal vectors means two vectors that are perpendicular. So if you notice, W1 and W2 are perpendicular with each other. So this is what we're going to do. We're going to break down vector v into two different vectors using vector addition. So that vector 1 and vector 2 are orthogonal or perpendicular to each other. So the first thing that we are going to do is we're going to find the projection vector. So we did that before. So that would be 2 times 3 plus 6 times 3. All of that is over the magnitude squared. So that would be 3 squared plus 3 squared. And then you're going to multiply that by your vector. So when it's all said and done, we end up with 24 over 18 times 3. And when it's all said and done, we end up with 4. So now I have vector 1 and I have my vector 2. So what we're going to do is, I have my vector 1. So what we're going to do is we're going to write down what we know, which is 2, 6 is equal to vector 1 plus vector 2. So what I can do is I can subtract 4, and that will give me my vector 2. So when I do this was actually vector 1. I apologize. I think I told y'all wrong on the previous, so go back and fix those. When you do this, your vector 2 ends up being negative 2. So when I write this as the sum, I'm going to come over here. Vector 1 is the sum of 4 plus negative 2. All right, so I just filled in the gaps, but I had to use what I knew in order to do that. Okay, now what I mean by go back and fix, this is vector 1, and I think at the end of this video, I told you that that was vector 2, and that is not correct. Apologize. So that should give you vector 1. All right, so let's go back and do number 5. So what we're going to do here is we're going to find our W1 so that we can use it to find W2. So here I'm going to do 5 times negative 5 plus 8 times 5. Put that over the magnitude squared, which would be negative 5 squared plus 5 squared, and multiply that by negative 5. When I do that, I get 15 over 50 times negative 5, and that gives me vector 1 of negative 3 over 2 and 3 over 2. So when I do this part, I go back and grab vector v. That is equal to negative 3 over 2, negative 3 over 2, plus vector 2. I'm going to subtract this vector, so that would be 5, 8 minus negative 3, 2. I apologize, I wrote down too many negatives. And 3, 2 for a grand total of W2 equaling to 13 over 2, 13 over 2. All right, so my vector V breaks down into my 5, 8 vector. I apologize, it does not. I've got all my vectors all confused this morning. So that breaks down into W1, which was negative 3 over 2, 3 over 2, plus our 13 over 2, 13 over 2 vector W2. Sorry that it ran into my space. I am writing extra large for some reason today. All right, so if you need to pause the video to get what you need off of that, please do. I'm going to have to erase that because I'll run into my other workspace. So it doesn't matter if they give you the component vectors or the linear combination, we're still going to do the same thing. So I'm going to take 0 times 8. There is no I in this vector. I'm going to add that to 2 times negative 6. I am going to take the magnitude of W and square it. So that's 8 squared plus negative 6 squared. So on the top, I get I left off my vector. I'm struggling today. And that would be 8, negative 6. So when I clean up the numerator, I have negative 12 over 100. I will multiply that by 8, the component vector 8, negative 6, and that gives me a vector 1, which is negative 24 over 25 and 18 over 25. So to find my vector V, or to break this down, I need to find V2. So I'm going to take 0, 2 and set that equal to negative 24 over 25, 18 over 25, plus vector 2. When you move this over and subtract it, your vector 2, or W2, I should say, ends up being 24 over 25 and 32 over 25. So vector V breaks up into negative 24 over 25, 18 over 25, and we're going to add that to 24 over 25, 32 over 25. That would be breaking this down into 2 orthogonal vectors. Our last one, we're going to do the same thing, find our projection vector first. So we're going to calculate W1. So that is going to be 8 times negative 1 plus 5 times 2. That is over the magnitude squared, which would be 5, negative 1 squared plus 2 squared. And multiply that by the negative 1 to W vector. So that is going to lead us to a numerator of 2, a denominator of 5, and then you're going to distribute that scalar. So that gives me negative 2/5 and positive 4/5. So in order to break this down, I'm going to take my 8, 5 vector V, set that equal to W1, add W2 to it. When you subtract, your W2 vector ends up being 42 over 5 and 21 over 5. So when I break V down, when I take this and break it down, I end up with negative 2 over 5, 4/5, plus 42 over 5 and 21 over 5. Now, if you were to add these two together, you go right back to 8. If you were to add these two together, you go right back to 5. So please make sure that your outcomes are matching. So if you have any questions about breaking V up into two vectors using vector addition, and those two vectors have to be perpendicular to each other, orthogonal with respect to each other, please make sure you contact me.